Yeah, g'day, it's Charlie ZL2CTM. Well, I just want to do a quick update today looking at where we're at with the radio, and in this particular case the receiver. So at the moment all the modules are in and they're all tacked down, they're all connected, which is good, as well as all the power supply going to it. So at the moment it's now a functioning receiver for both CW and for SSB. So just to sort of briefly go through the configuration, it's pretty well in line with the original thinking in the schematic that I was thinking about back in the first video with the thoughts and ideas. And there may be some subtle changes from the transmit site, but certainly from the receiver it's about right. So at the up top here, just make sure we can see that, RF is coming in and it's going through the TR relay here. That relay is also switching the 12 volts coming in between transmit and receive. Which is over here onto this little bus bar over here. RF then goes through into this relay here, which is switching between the 40 meter and the 80 meter bandpass filter. So if I was to flick the old band switch here, you'll see that relay clicking up and down, which is basically just, like I say, switching into the circuit, one or the other of those two filters. Being a radio, this radio here is below 10 megahertz. I'm not worrying about having an RF or an antenna amplifier or an RF amplifier prior to the first mixer. So that RF there, once it comes out, it's back through this relay here again, and the reason for that is I want to share these bandpass filters between the transmit and the receive circuitry. I don't want to have to build another set, so I thought I'd just do some, I won't say fancy, but some additional switching through this relay here to allow that. Anyway, suffice to say, that relay, once it's been through the bandpass filter, which is very good too at removing any broadcast signals, which can be a problem with high strength broadcast transmitters in the area. It comes through here and into this relay here, which it's a little bit unconventional, but if you look at that previous video, I'm using that relay to switch between, in fact on both sides of the IF amplifiers and the crystal filter, these two mixers here, the SBL-1s, on receive this is the mixer and this is the product detector, and on transmit this becomes the product modulator, and it becomes a channel mixer, which then brings it up to our desired transmit frequency. To allow that to happen is using these two little relays here. Anyway, that RF comes in, gets applied to our mixer, and from the SI5351 we have our VFO. We'll go through how I set that up, or the approach I've taken for that, in just a sec. But the output of that then is our intermediate frequency, which then goes through the first IF amp. You'll note that I have now wound all the various transformers on FT37-43s, and I've just elected to use a mixture of 24 and 26 gauge wire for that. What I essentially did is actually just pulled out the junk box some relays which I had already left over for some previous projects, and then just counted the turns and just removed where I needed to. Anyway, so these two relays here are basically switching into that IF strip there, either the SSB or the CW filter. That's all functioning and working, and we'll see that in a sec. And once it comes through the other side, back through the second IF amplifier, and on our receive side into our product detector, where it's mixed with the BFO frequency, and the output of that is the audio frequency, which is then amplified and played out the speaker. So yeah, just a very standard, nothing flash, single conversion super heterodyne receiver. Right, so the interesting part is trying to work out where to place both the VFO frequency and the BFO. I'll try and explain this on a piece of paper, and hopefully it'll make some sense. And if I get it wrong, I apologise. But here we go. So, what I just spoke about before with the single conversion is depicted up here. So we have our RF coming in into our mixer, first IF amp, the crystal filters, second IF amp, and then the product detector. So from the SSB point of view, not labelled, but I'll do that. SSB, CW. So I'm using as a test frequency 7.090 megahertz or 7090 kilohertz. It's a lower sideband signal, so below our suppressed carrier that's being transmitted, we have our intelligence sitting in that lower sideband. Upper sideband, of course, has been removed because this is a single sideband, in this particular case, a lower sideband transmission. Point to note is the start of that intelligence is 300 hertz away from the dial frequency. Right, so what I need to do is I need to transpose this in frequency, this intelligence here, all the way up in frequency to sit inside the passband of the single sideband crystal filter. So that's what I need to do. Now, I'm using high side injection, and what I mean by that is my VFO frequency is above the IF frequency, so I'm going to get something called frequency inversion. So that's why I actually, even though this is, you would think if it was low side injection that I would park this frequency here, I'll shift it up to just sitting on the high side or just above the pass band of that crystal filter, which means that intelligence there would be sitting inside. But again, because I'm using the high side injection, that process gets flipped on its head. Suffice to say, the VFO frequency which I'm using to apply to this first mixer to create our product and our difference frequencies is our frequency of operation, in this case 7090 kilohertz, plus the center frequency minus half the bandwidth, so 2900 divided by 2 gets us to our minus 3 dB point, and then, as I mentioned over here, another 300 hertz, so minus 300 hertz again, gives me the frequency that I'm going to be that I'm going to be feeding into that first mixer, and through sideband inversion allow me to park or to place that lower sideband intelligence inside the passband of that crystal filter. Once it's been through that crystal filter and amplified some more, it gets applied to the product detector, and I now need to move that intelligence that's sitting centered around 8.99 megahertz. I need to move that down to baseband, or in other words, I need to move that down into audio frequency. So to do that, I need to mix that signal with some more RF to get my sums and differences, of which the difference will be my audio frequency. So if that's the case, if that intelligence there starts at 300 hertz and goes up to approximately 3 kilohertz, then you can see there that BFO frequency needs to sit around here, and that's exactly what I've done. So the BFO frequency is that minus 3 dB point, which is that frequency there, with another 300 hertz taken off, so 490 becomes 190, and that's what's getting fed into that product detector, and that's exactly what's happening in the circuit. CW is subtly different, so what I'm going to do here, and the approach I've taken, is to shift our received frequency, so that actual frequency has been transmitted in this particular case on 7090 kilohertz. I want to shift that up, and I want to park it right smack, or place it right smack in the middle of that really narrow CW filter. So any other signals that are on either side of that in real life fall outside and are attenuated. So that's what I need to do there. So my approach for this one is to work out what that center frequency is, and then my VFO is simply my frequency of operation, which is this one, plus that center frequency. And if you do the math, so when it comes out of that first mixer there, it'll sit, the frequency that's coming out will sit right smack in the middle of that passband of that little narrow CW filter. Now, I want to have a baseband tone, so when I'm now applying this to the product detector, and I want to recover my audio frequency, every time that CW is pulsing, I want to hear that CW frequency in my ears at 700 hertz. That's the frequency I want to select. So to do that, I then need to, which is very similar to here, I now need to mix that signal that's sitting up at 8.996856 megahertz with a BFO which is 700 hertz away to create that 700 hertz difference frequency that comes out of the product detector, and that's what I hear. Right, so I hope that was a little bit clearer than mud. It's a little bit hard to explain, but it's yeah, that's what it is. Right. Okay, so what I want to do now is do a quick test of the receiver, just a functional test using some test equipment, and then later on tonight I will put it on to the antenna and actually see what's on the bands once they start to listen up, or to wake up I should say. So at the moment I'm going to use two things here. I'm going to use the SIGGEN for CW, and just up here we've got a small little radio which I will modulate using a podcast off the phone, and like I say, we can key that up and we can generate our SSB through there. So CW first, that's the one that's currently set up. So down here we have 7090 kilohertz or 7.090 megahertz tuned in. We are on CW. Over here we have the same frequency dialed in, which I'll then key up, and we should start to hear that coming through. And if we were just to tune off, I'm on 10 hertz steps here. You can hear that winding in and out. So like I said before, I want that tone that's coming out to be a 700 hertz tone, and I can test that by using just a simple audio generator that I've got on the phone here. That's currently set up for 700 hertz, and you can just start to hear, if I turn the volume up, that ever so slight beat frequency there. So we're not exactly on 700 hertz, but we're pretty close. So if I was just to wind the frequency here up just a tad, let's go back to frequency. So 5 hertz. So we're 5 hertz off. I'll live with that. I'm not going to complain too much about being 5 hertz off. So yeah, so that's good. So I'm happy with that. So that's doing exactly what I want. It's putting the CW signal right smack in the middle of the pass band of the filters. So anything that's sitting on either side of that in the real world is being attenuated out. And because I'm mixing the right beat frequency with that, I'm generating in baseband my 700 hertz signal that I wanted to hear out the speaker. So that's good. Let's just swap over to single sideband. We'll just start up that podcast, and we'll just play that. Good old security now. I recommend that to anybody to listen to. So that's now playing, and what I should be able to do now is key up, and
Party conference
we'll start to hear that coming through.
That the UK government will look to pass new legislation in
so again, I can tune off there.
Data protection laws in Israel, Japan, South Korea, Canada, and New Zealand. Now, on the one hand, that sounds maybe better than
so
GDPR.
I know what this guy normally sounds like on the podcast, and that's frequency-wise, his voice sounds good. So I know then I've got the BFO sitting in the right place to generate the right range of audio frequencies out through the audio.
How the internet.
So that's pretty good. I've tried to turn that down as low as I possibly could. Just got a bit of a sniffer antenna here, trying to pick that up. Maybe just unkey that. So yeah.
Want to have borders, but the internet was designed to ignore them, and
unkey. So I'm happy with that. So at the moment, just like I say, using that sort of rudimentary test here with some test equipment, it's certainly demodulating, which is great. So like I say, I will pause here and flash it back up tonight, and we'll see if we can hear on the airwaves, more the point. So I was just sort of thinking about the transmit side, and then it's just a matter of starting to think about how am I going to do the transmit, or more the point, just fixing up the transmit. I'm still thinking about utilising that third output of the SI5351 to generate directly from the key the frequency of the CW signal. I'm debating. I do want to test to see if I was to feed that through the bandpass filters, how clean the signal looks coming out before being amplified. If that's not good enough, then I'll certainly look to filter that signal coming out of the SI5351 to clean it up a little bit more before feeding it into the bandpass filters. And then we'll just have to work out through experimentation with the off-board amplifier. So as you see here, I've actually got heaps of space here to do an on-board amplifier at some point, but that'll be, I think, another project. Do I need to have a little bit of extra amplification on that CW signal, and actually also on the SSB signal before being fed out the antenna? Everything is configured from a voice side of the house. Microphone amplifiers all set up. However, I've just noticed, because I was only concentrating on the receive side, I actually haven't wired up the DC voltage going to that, so that's something I will have to fix, but otherwise everything else is configured correctly. But like I say, I was only concentrating on the receiver at this stage. Okay, I'll pause here, I'm starting to ramble, and I'll catch you later on tonight.
For some unknown reason, the bottom...
Yeah, the New Zealand Homebrew net has just started up.
But anyway, we'll go out and hit it home tomorrow with a bigger hammer. That's what we'll do. So now TJU, over to you, Les. I hope you've had a good Monday. Oh no, Mondays used to be your day.
I might have to put the big speaker on, get a little bit more bass coming through.
Today, Les. So now 2JU, so now 2 hope you're quick. 2 weeks, sorry.
There's a nice strong signal there.
Yep, Roger Laurie, CL2HQ, CL2JU. Good afternoon, and I'm just out of the room, so I don't know who else is on. But anyway, I'm here, and John's there here too.
Heaps of headspace on that audio amplifier. So what I might do, I might, rather than just sort of playing this whole net, I might just turn the camera on and off as different channels come up, or different operators. So we have a good range of signal strength. So this is currently 5:30 and basically early summer on 40 metres.
25 plus 2 adults, a teacher and a helper or whatever.
I think that sounds quite nice for such a small speaker.
Asking lots of questions and looking and making quite a lot of noise.
Funny old thing.
The highlight of the afternoon. The morning was
saying the AB works on 77 should be the there was just before a bit of FT8 coming through. Now that ticking sound you can hear, I live next door to a farm, and quite often the farmer's electric fence is not earthed correctly, and I get the old there it is. I quite often get the old I quite often get the electric fence noise coming through, which is a bit frustrating. So the old AB, VFO AB works well. Yeah, so what I might do, I'm half tempted just to maybe do a couple more recordings of this particular net, and I might just package this up and put it up, because the whole idea of this video is just more of an update on where I was at with the radio, and go from there. So like I say, I'll do a couple more in a sec, and then I will package it up and send it on.
Right, we're going to go to Giovanni, Mike, Stu, and then John, and then yourself for standby. Hey, Earl, you're not old, mate. You're the same age as me. You're in better condition than...
There's a little bit of signal fading coming and going there. Okay, let's not just listen to that. Couple of things I want to point out. The good thing is, if I was to tune off this frequency, we can hear the atmospheric noise there. If I was just to go up and to put the antenna on to off the antenna, the good thing is we have that noise dropping away. So that means that I'm not generating any more internal noise above the noise floor of the RF. So again, the noise floor of the environment outside, which is good. As an aside, when I first put this together yesterday, that wasn't the case. And I had quite a bit of internal noise coming through, which just wasn't right. And I noticed when I used the oscilloscope and I probed the output of the mixer down here, that I was getting a very strong local oscillator frequency being passed through that first IF amp, which is not right. This balanced mixer here should have taken that all the way out. And as it turned out, that particular SBL1 was bad. put a new, well, I put another one back in, and the problem disappeared. So that's good. So I'm back to where I should be, i.e. I'm not generating a large amount of internal noise through these BJT amplifiers, which is great. Second thing, the SBL ones are 7 dBm devices, so they're looking for a local oscillator drive of 7 dBm, and for simplicity's sake with the oscilloscope, that's 1.414 volts peak to peak. Now in the software, which I'll put up on the blog, you will see where the SI5351 is initially set up as an object within the code, that you can set the drive level of the outputs. I started at 4, it goes in milliamps, and that was coming out at 1 volt peak to peak. I then upped that to 6, and then ultimately I'm now set back to where I thought I was going to be, but I wanted to check it out anyway, which was the 8 milliamp setting, which comes out to be just on just under 1.5 volts peak, which I'm quite happy with that, and I'll leave it at that. So just a note that when you are setting up the SI5351, certainly within the library that I'm using, that you need to set the drive levels. The other thing I didn't bother doing a video on, if you look through some previous videos you will see tuning the SI5351. This particular library that I'm using it from Ethernet has a sketch that you load up, and through the serial control panel you can tweak a calibration factor to then get exactly the right frequency coming out. And the way in which I determined that was exactly the same process I used to do the crystal filters. I set up the SIGGEN over there to output the 10 megahertz signal out the antenna. I had a general purpose receiver sitting off to the side here, and that particular test sketch outputs a 10 megahertz signal, and then through the serial control panel I adjusted that calibration factor to essentially null out any beat frequency, so therefore then I knew that I was actually outputting the right frequency. And what you then use, and if you look at the code, you'll see that there's a calibration factor again in the same area where you set up initially the object for the SI5351, and you'll see a calibration factor. The calibration factor that's in there was the one that I set up, or more the point I determined, by running that calibration sketch. And again, if you look through some previous videos, you'll see how that was done. It's pretty straightforward and easy enough to do. Rightio, I think I have talked myself dry, so I think I might package this up and upload it. Hopefully it'll provide a little bit of background into my thinking in terms of setting up the frequency for the VFO here and the frequency for the BFO on receive, noting that on transmit these will invert over, so the signal path through the IF stage is always the same. And I did that, and again I know I'm repeating myself here, and the reason why I did that is to keep the outputs well away from the inputs, the outers from the inners, and by doing that you minimize, and in fact in this particular case you eliminate it, but the possibility of feedback. If you have some of the other ways of actually switching the IF between transmit and receive, you can quite often get the outputs very close to the inputs, and you get feedback. But this approach here that I've been using for quite a while now works just fine. Okay doke, that's enough for now. I'm going to wire up the DC supply to the mic amp, and then I think I might start doing some transmit checks on SSB, and then I will need to then shift my thinking of how I'm going to approach the CW side of the house. Anyway, 73 all. I probably won't be doing another video for a little while. I've got quite a few activities coming up on the next few weeks and weekends leading up to Christmas. But in and around that, I'll certainly endeavour to keep melting solder and keep playing and keep uploading videos where I can. Again, normal, what do they call them? The old service announcement. Not a tutorial. This is purely a video log of the approach that I have taken in setting these things up, and take it for what it is. Okay, 73 all. See you soon.